Alrighty, so what we're going to work on today, I don't know why I always say alrighty, need to work on that. But we're going to talk about applying properties of rational exponents to simplify expressions. What that basically means is that we're going to have a fraction for an exponent, and we're going to talk about what that means for us. So let me give you a little bit of information. First, just some vocabulary about roots so that we all know what we're talking about. Okay, so this is a normal square root sign. Okay, but sometimes you have a number out here. I'm going to draw this again because it's like sideways. Here we go. Okay, so sometimes we have some number out here. This time I'm going to call that n. Okay, and then maybe we have some sort of number inside here. And so the parts of this that we're going to use and the words that you're going to hear me saying, this symbol right here is the radical symbol. Okay. The thing that is underneath this, we call that the radicand. I just want to double check that I'm saying all these names right, because I don't want to confuse anyone. And then this is what we call the index. Okay. So when you have a square root like this, square root of 16, you know that that truly means what is it that we multiply together to get 16? 4 times 4. Okay. And so the square root of that is 4. Additionally, when it doesn't have an index right here, okay, no index, we assume that that is going to be assume. I don't know how to spell assume. I'm going to move this out of the way though, because it's running into it. Assume that it is 2. Okay, so those are just some things to know before we kind of really get going. The next thing I'm going to show you is what I meant before about when the exponent is a fraction. Okay, so let me give you an example here. Let's say that we had something like x to the 1/3 power. Okay, we can convert that. This is called exponential form, but we can convert that to be in what we call radical form. And so what that means is that this number right here that's at the bottom of that fraction is our index. So we put the 3 right here. Okay, whatever our base of our exponent is our radicand. Okay, and so that's how you would convert this. Now, what if you had a fraction that didn't have a 1 on top? What would you do then? So let's say we had m to the power of 3/5. Okay, so we know we're going to have the radical symbol. So let's go ahead and draw that radical symbol. Okay, we know that our base m is going to be our radicand. Okay, the number that's at the bottom of our fraction, the denominator, comes right over here to be our index. And then what do we do with that to the 3rd? Okay, that actually stays right here as an exponent on the m. Okay, so when you're converting these from exponential form to radical form, you're taking the denominator of the exponent and making that the index of the radical sign. If you happen to have a numerator, part of the fraction is in the top, we're going to keep that with our base. Okay. You can also go the other way. So let's say that I had y. Let me put it before I write. Okay, so I'm going to say 7, and I'm going to say y to the 3rd. okay, I can convert that the other direction. Okay, so I know that I have y to the third, and then what's my denominator is this 7. Okay, so I can go both ways. I can change it from exponential to radical form, and I can change it from radical form to exponential form. Okay, the problems that you're going to have that deal with that are those first few, just to get you practicing with that. Okay, so I'm going to erase this board. You can back up if you need to write notes, which I definitely encourage because I said a whole bunch of vocabulary for you and gave you a lot of things to think about. Okay, so the next thing that we're going to talk about here is, let's see, we talked about that. Okay, so we're going to talk about when you have an expression that has numbers in it. This one doesn't have any variables, no x, no y, nothing like that. And so let me show you how you could think through problems like this. If we have, well, actually, I think I'm going to start with the exponential form. Okay, so your exponential form is, let's say, 243 to the 1/5 power. Okay, so then we're going to convert that to radical form. So square root of, and our base is 243, and the 5 goes right here. What that's saying is the 5th root of 243. Okay, so some number, I am going to throw an X at you, but just as an example, some number to the 5th power equals 243. We're trying to figure out what that is. Could also write it like this. What times what times what times what times what? There's 5 of those, equals 243. That's what we're saying when we have this. Okay, so now we sort of just have to figure out what exactly is that. And you know what? This can be tricky. Okay, sometimes you're going to have a number that pops into your head and you're going to know it. Sometimes you might have to factor it a little bit to see what it might be. Okay, so I'm going to think about this and I'm going to say, okay, 243, it's not an even number, so I know 2 is not going to be part of it. My next question is it divisible by 3? So remember the rule for that is if we add the digits, so 2 plus 4, which is 6, plus another 3 is 9. If that, what you add together is divisible by 3, then the whole number is divisible by 3. Okay, so I'm going to just start making a factor tree and think about this. Okay, so 243 divided by 3 is, and I'm going to get my calculator, 243 divided by 3, 81. Ooh, that's fantastic news because that is a perfect square. Okay, 81 is 9 times 9. And each of these 9s are really 3 times 3. And check this out. We have 3, that's one of those, times 3, times 3, times, and now I'm at this bottom 2, 3 times 3, which is what we were hoping for. We were hoping that we would find something 3 to the 5th power equals 243. Okay, and so the answer to this question is 3. Now, you do have a button on your calculator for this. Okay. When you look at your calculator, and I don't have every single calculator available, so what you're looking for on your calculator to figure out what this button is looking like is it says, mine says this. Oops, I'm still on marker eraser. Okay. Mine says X like that. Okay. And so what I have to do is mine is on the second key because it's the little tiny blue one that's above my exponent symbol. Okay. So I'm going to press second, and then I'm going to press my exponent button that gives me this. Okay. But actually that doesn't work that way. What I have to do first is type in my 5. Okay, so I'm going to type 5. And then I'm going to type this button. So second, and then that button. And then I'm going to put in 243 equals, and it tells me that it's 3. Okay, so that's how you can use your calculator if it's like a calculator portion of a test. Some tests, you're going to see this kind of question and you're not going to have a calculator available, okay? And the questions that I'm going to ask you on the test are not going to be quite this straightforward, because we're going to talk next about what to do if you have some of these, like a variable in it, okay? So you can use the calculator for the number part, not so much on the variable. Okay, so let's look at another question. If you had something like a number, okay, so here is a number. What number do I want to use? Do I have a good example? No, maybe I do on this side. You know what? Maybe this is actually for the next lesson. I bet it is. So let's just do this example because I think it'll be a good one to do. Is what if I have a fraction? Oops. Okay, so a fraction. This one is in the checks. So 81 over 256 raised to the power of another fraction. And this fraction is 1/4. Okay, what the heck do you do with that? Well, first of all, the exponent has to go both to the top and the bottom of my fraction. Okay, so if you want to think about it in two different pieces, you could think about what is the 4th root of 81 and what is the 4th root of 256, and then combine those in the end. So that's what I think I'm going to do, because I think that's easier for my brain. But if you want to keep them as a fraction while you do this work, that is totally fine with me. Okay, so the 4th root of 81, well, I happen to know that the square root of 81 is 9. So that means 9 times 9. I like making these factor trees. That really helps my brain think about it. Okay, so there we go. We have 1, 2, 3, 4. That means the 4th root of 81 is 3. Okay, now 256. That one is also a perfect square. 256. I'm just going to double check myself because sometimes my brain says silly things and then I don't know what I'm talking about. Okay, I was right. So 256, square root of that is 16. And the square root of 16 is 4. So easy again, the 4th root of 256 is that bottom row of my factor tree, which is 4. Now I'm going to put those fractions back together. 3/4 equals 0.75, however you want to write it. There we go. Okay. So with that, that's really what this entire lesson is about, is converting these fractional exponents into radical form, or going the other direction, radical form to exponential form, and then simplifying those. Okay. Let me know if you have any questions.